last time we talked about how we could get a classification task to output three things at once. You know, like we basically have three classes that we want to classify from, and we get an associated probability with each one. And how do we interpret those probabilities as actual probabilities that sum sort of to one? Now in this video, I'd like to talk to you about the actual method that's used in deep learning. So this is not the method that's used. It's very, very close to the method that's used. I just want to point out a fact to you that if you have a number x1, x2, x3, all the way to xn, that you want to make these numbers sort of sum to one, then what you could do is you could just divide by the sum of all of the numbers, where the sum is just x1 plus all the way to xn, right? If you divide this by the sum, divide by the sum, and then divide this by the sum, then if you add these all together, what will you get? If you add the numerators together, you'll get x1 plus dot 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 all the way to xn. And then in the denominator, you'll still have the sum. But this is the sum. So therefore, you'll just have these cancel out, and then you'll get 1. And the reason that we wanted them to sum to 1 was that now this thing can be interpreted as a probability. The probability that is it of class 1 or not? Is it of class 2 or not? Is it of class 3 not or not? You know, all the way to class n. So we get multiple outputs, and then we can sort of put them together in order to make our final decision. So this is almost how we do it in actual deep learning. The problem with this is that sometimes your outputs could be numerically unstable. And so one thing that we want to guarantee is that this sum is going to be a positive number, or it's like basically this sum is like not zero at least. And so there's a function called the exponential function, exp, which is essentially just e to the power of the input, that is always positive. So this is always positive. It's never even zero. It's never negative, and it's never zero. So this is what it looks like. It kind of looks like this. This is the exponential function, right? Where over here, at x equals 0, the y value is 1, because e to the power of 0 is equal to 1. And it becomes bigger and bigger and so on. And so for numerical stability, for the sake of numerical stability, each value x, let's say I, will be transformed into e to the power of xi, so e to the power of whatever that is, divided by e to the power of x1 plus e to the power of x2 plus dot 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 e to the power of xn. So let's rewind that. What does that mean? Well, that means that essentially you have x1, x2, dot 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 all the way to xn. And what we could do is divide by the sum, but before we divide by the sum, we're actually going to transform all of these numbers into e to the power of x1 and e to the power of x2, and then all the way to e to the power of xn. And then we'll divide by the sum, where the sum is equal to e to the power of x1 plus dot 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 all the way to plus e to the power of xn. And so we'll divide by the sum, divide by the sum, divide by the sum, right? And what this will do is all of these will be positive. That's one thing. And like probabilities have two things to them, right? Probabilities have to be, each of the probabilities has to be positive, and the sum of the probabilities has to be equal to 1 exactly, right? And so by doing the e to the power of all that stuff, we guarantee that they're all positive. And then by dividing by the sum, we guarantee that the sum of them will be equal to 1, right? And so if you put these two things together, and what you get is each xi gets transformed into e to the power of xi divided by, the sum of all of the exponential powers. And this is the associated probability for class I, where this is I, right? So class I. So the probability that that thing that you inputted is of class I. Now, this has a name in deep learning. It's called the softmax function, softmax. And yeah, that's sort of what I wanted to tell you about in this video.